In chapter 1 through 4, we've looked at static charges, meaning our charges don't move, and that's why we call it electrostatics. And now we're going to look at moving charges. The book describes the Druid model, and that helps us to understand how electrons move through conductors and how current is created. And so we did an activity on this in class, and when there's no electric field applied, then our electron here just randomly bounces around the lattice structure of the material that it's in, but it really doesn't end up having much of a path. It doesn't really move to the right. So if we compare that to what happens when we apply an electric field here, then if we're starting here and we're bouncing around, which is slowing us down, but we're also moving to the right, we're drifting to the right. And that's caused by the push, right, or the force that the electron feels by that electric field. I'll talk a little bit about current density and conductivity. So current density tells us how fast charges are flowing by, if we consider how many charges are flowing by and how fast they're moving by at a certain point. That gives us an indication of current. And so that depends on the number of charge carriers, the charge of the carrier, and the velocity, the drift velocity. And the current density is proportional to E. And that would make sense because when I have an electric field in a wire, that's going to push the electrons through, and so we're going to see electrons moving by with a given velocity. So it would make sense that our current density is proportional to our electric field. And notice in chapter 5 that they talk about the conductivity of the material, and they call that sigma C, which I think is somewhat confusing because in a previous chapter we used sigma to define surface density. So just note that really we're using sigma here to talk about conductivity. And so you just notation is a little bit confusing, so just keep that in mind. So the current is the rate at which charge flows across a boundary. So it's dq dt, the charge. So like imagine an electron flowing by in a certain amount of time. And the unit of current is the ampere. So the ampere is coulombs per second. And there's some examples in table E5 of the conductivity of certain materials, and that's given in E5.1. So if you think about the microscopic view of current, so we want to know how fast the electrons are moving by, and that has to do with both the type of material, so what the lattice structure is like and how much these electrons are going to bounce around in the lattice structure, but also so that would have something to do with the collisions and also the mean free path. But then the electric field, right? So the electric field also causes them to drift. And so if electrons are moving to the left, then if I think about that, they're going to be moving towards a positive charge. Oops.